Hey there! Welcome to the final part of episode 4. Earlier in the episode, we looked at some major components of our player scene, handling collisions, drawing animated sprites, and moving the character around using a state machine and a camera viewport. You can find those previous segments on our channel. In this last part of episode 4, we'll be putting the finishing touches on our player scene with some lights and sounds. By the end, we'll be able to add some basic lighting sources, cast shadows with occlusion shapes, and playback music and sound effects. Stick around to the end of the video for a quick preview of what to expect in our next major episode, number 5, where we'll finally look at the level scene and building the game world for our player using Godot's tile map system. So let's get started. First up, let's make music with the simple audio stream player node. This is how we'll bring the game to life with sound. There are more advanced ways to manage audio in a Godot game, but this will give us the foundation we need. Our player scene has these basic sound effects. A jump sound effect that plays when the player jumps and the state machine moves them to the air state. A hit sound effect for when the player is taking damage. A gunshot sound effect for when the player fires their pistol. And the cliche sound of a coin being picked up for when the player picks up items in the game world. The most important setting on an audio stream player is the stream resource property. This is the raw audio asset for the sound. We'll use MP3 files for the stream for our node, but you can use other formats as well. Another important setting is the volume in decibels that can be adjusted as needed here. You can also adjust these other settings, but we don't need them for our demo game. If you want to preview a sound, you can click the playing checkbox. This will play the sound from the editor and then turn the checkbox off automatically. An audio asset can have a short duration like a quick sound effect, or they can be longer musical compositions. In addition to the various sound effects we just mentioned, we also have the music that'll be played when the player's game over screen is displayed. This works just like sound effects with one minor difference. We set the process mode to always to play this sound continuously even when the game engine is paused, which happens during a game over screen. To play any of these sounds in code, we'll set up some reference variables like this. And we'll start and stop the sounds using the play and stop methods on the variables like this. And that's pretty much it for basic sounds. Once we have those nodes in place, it's mostly about when and where to start and stop those sounds from within code. We'll see more sounds when we get to episode 5, but those work the same way as these sounds on the player node, with a few minor exceptions. Next, let's shed some light on the game with Point Light 2D. The Point Light 2D casts light onto a 2D environment, originating from a single point. Our player scene has one of these as a child node, meaning that this light will follow the player around as they move. We can easily position the light relative to the player's sprite. There are more light sources in the level scene, but because those are not part of the player scene, they won't move around with the player. We'll see those in episode 5. There are a bunch of other settings for this node, perhaps the most important property being the texture value. Just like sprites, this is the raw light image that is overlaid onto the scene. It represents the appearance shape of the light. The scale node simply represents how large the image texture should be. The color of the light can be selected here. And the intensity of the light can be set here. The larger the value, the stronger the light. You can configure lights to affect only certain canvas layers or even Z height layers here. We set the mins way low and the maxes way high to cover a very large range of objects that should be covered and affected by the light 2D. If you ever find that your lights or shadows are not being displayed in your game, be sure to check the layers and the Z ranges are wide enough. The objects to be illuminated must fall between these values. Lights are cool, but the absence of light is just as neat. We'll look at casting shadows in a moment, but for now, take note of this section in the Point Light 2D node in the inspector. This shadow section controls how the light will behave when other objects want to cast shadows by blocking this light. For a light to cast shadows, this enabled field must be set. We can choose the color for the shadow here, and generally this will be partially transparent. For now, we'll keep the filter at PC4 and we'll use a smoothing of 0. You can read up on what those advanced settings do in Godot if you're feeling adventurous. Finally, we must make sure that the item call mask values and the visibility masks on the light node match any objects that we want to interact with shadows. You can make some interesting effects using a combination of all of these masks, but for simplicity, our demo game will only have the single layer to handle lights and shadows. All nodes in our game that cast shadows will have the same call mask layer and light visibility layers. If we simply drop a point light 2D into a scene, even if that point light 2D has shadows enabled, it won't cast shadows by itself. It will just make everything around it brighter. No, instead we need to tell the game what other objects should block the light. To do that, we'll use a node from Godot called the Light Occluder 2D. This is the node that actually blocks the light and causes the point light 2D to cast its shadow colors. By giving an object a light occluder, we can define a 2D polygon shape that will act like a physical barrier and block the light from the light source. Depending on where the light is, how far it is away, and the shape of the occluder, we'll get our shadows cast out onto the game world. Since we don't have any occluder nodes on the player's scene, let's get ahead of ourselves a little and talk about two of the occluders that we'll see in episode 5 in the level scene. Here is an example of an occluder on the in-game hazard tiles. Here, we set the occluder polygon shape using a set of 5 points to form a square. Remember to check the occluder light mask like we mentioned before. With this occluder in place, when the player walks near a hazard tile in the game, the center of the hazard will cast a shadow out and away from the player. Because the occluder does not cover the entire sprite of the hazard tile, notice how the shadow originates from within inside the tile. This gameplay footage also highlights the second example. The tiles in the tileset can also occlude light. Each tile in the tileset atlas can be given an optional occlusion shape. You can find this setting in the tileset editor, under the rendering section when looking at a selected tile. Here, you can see that much like our hazard occluder, we'll have a square shape. The main difference here is that the shape covers the entire tile. You can see how that affects the shadows that are cast by the tileset versus the shadows that are cast by the hazard tiles. And there you have it. We've completed our journey through episode 4, exploring the nuts and bolts of the player scene. We've covered a lot of ground, moving the player around, managing collisions, drawing animations and sprites, and now using lighting and sounds. But our adventure doesn't end here. In the next major episode, number 5, we're going to change gears and look at the main level scene and all of its components. That's where we'll build a game world for the player to explore using Godot's tile map system. We'll also look at item upgrades, placing hazard tiles, adding basic enemies, and even a scripted boss battle. Episode 5, spanning 3 sub-videos, is coming soon, so stay tuned for more game development goodness. Thanks for joining us on this incredible journey. Until next time, happy game developing.